All right, we are going to be solving some equations today, and I want to bring back graphs one more time so that you can see the connection between the graphs and the equations. So we have different functions. Make sure you are using the correct function. And remember, if it equals something, that's an output or a y value. And if the parentheses are filled in, that's an input or an x value. So to start off, we are going to have f of x equals 8 and f of x equals g of x. What I want you to do is go ahead and pause the video and set up what equations you think these will be, and then you can go ahead and play the video to see if you got it correct. Okay, there you have the equation set up. Make sure you're just matching up the correct function. Now go ahead and see what you remember about solving. In the end, we want to know what x equals in 1 and then what x equals in 2. Go ahead and pause and then play to check your answers. All right, for number 1, you should get x equals 1, and you can even put it in function notation since that's what's given to you. F of 1 equals 8. Now for number 2, I kind of did 2 steps in one. You want to get x onto one side. Right now it's on 2 sides of the equal sign, and you want to get the constant onto the other side. And so in one of the steps, I added the 1/2 x, and then another step subtracted the 5. So in the end, you should have something that is 3.5x equal to -7. And then when you divide by the 3.5 on both sides, you get that x equals -2. Again, you can put in function notation. F of -2 is the same as g of -2. Now, how would we do this with graphing? Well, let's go ahead and get f and g both graphed. Now, look at the form they're in, and we have a ton of different graphs this year. Is it a line? Is it a parabola? Is it a square root? Is it absolute value? I hope you're looking at this and you can see a little mx plus b setup. So go ahead and graph with what you remember. You need your y-intercept and you need your slope. Pause the video, graph, and then play to see if you graphed correctly. Okay, there we have both functions. A +3 slope, rise 3, run 1. A -1/2 slope, drop 1, go to the right 2. So now let's see what it's asking us. If we want the output of 8, that is saying a y value of 8. So on the y-axis, 8 is right here. And if I trace it over, here is the point at 8 on f. And if we trace it down, it is at x of 1, like we had said here. Now the functions in number 2, f of x equals g of x, that means they are the same. In lines, that means they overlap at the same point. Well, that overlapping point happens right here. And we want to know what x value it is. If we trace it up, we can see that right here is -2. So if you were asked to solve, you don't need the graph, but if you were given a graph, perhaps you're like, wow, graphing lines is really quick, and I just have to take a look at their output and then check what x value that happens at. That could be pretty quick for you as well. Okay, let's see this with another example. Okay, we are moving on to h of x. Well, h of x is the square root of x plus 3 minus 5, and we want that to equal -2. Actually, I just want to double check x plus 3 minus, there we go. All right, so it doesn't matter, you could solve, you could graph, it doesn't matter the order. If you would like to solve first, notice I put PEMDAS here because when we solve equations, we solve them in reverse PEMDAS. You see the equal sign? That means you are starting at addition and subtraction and moving up. So if we are going to solve this, we want to take care of whatever is addition or subtraction first. So that means that this 5 happens first. So we get the square root of x plus 3 equals +3. Now we do have that +3 under the square root. However, it's trapped by the square root. We can't access it until we get that square root taken care of. So for now, our addition and subtraction is done. There's no multiplication or division happening outside of the square root, so that is done. And now we move to exponents. Square roots don't look like exponents, but they are in the exponent step because you're asking yourself, how do I undo a square root? Remember, roots and exponents are opposites. So if we have a square root, the way we undo it is an exponent of 2. If we put an exponent of 2 on one side, we put an exponent of 2 onto the other. Whatever we add to one, we add to the other. Now on the left side, that squared and square root cancel, freeing up the x plus 3. On the right side now, we have to calculate 3 squared. Remember, that's 3 times 3 to be 9. And now we've done our exponents. There's no parentheses, so now we just do our last step of minus 3, and we get that x equals 6. In function notation, h of 6 equals -2. Let's see how we would do that with the square root. If we wanted to graph the square root of x plus 3 minus 5, think back to your square roots you did in your activity these past few days. I want you to pause the video and see if you can graph it without me, and then you can play it and check if your answer is correct. Okay, did you start at -3, -5? Remember, whatever makes x 0 is the x you start at, and the back number stays the back number. And then with square roots, remember, we went to the side by the odd numbers. So you can see I went up 1 over 1, up 1 over 3, up 1 over 5, and if we had room, it would be up 1 over 7. So in the square root, we go sideways by the odd numbers. And now we can see that if our output is -2, -2 is our y value, which is right there. And if we trace over, that's the point we want to look at. And if we look up, this is the x value 6, like we wanted to get here. Now 4 is a little tricky because I want you to take a look at the graph for this one. Because it's already graphed, we can solve 4 with the graph. We want to see when the output or the y value is -8, well, that is right here. And if we do the same thing, like that horizontal line, our horizontal line never crosses through our square root graph. That's because there are times when there are no x values that get us the intended output. So there is no x that says if we input x into the square root, we will output -8. So something like this, we would say does not exist, or DNE. There just is no way our square root will reach down to -8 because our starting point is the minimum point. Okay, moving on to p of x equals -1. Let's take a look at p of x. And we can see that it is an absolute value, so maybe already be thinking what that graph looks like. For setup, we will say our p of x function equals -1. I'm going to go ahead and bring back our reverse PEMDAS. Remember, anytime we have the equal sign, we will start here at addition and subtraction and work our way up. So we see this -4 behind it. We can go ahead and add 4 to that to take care of our addition subtraction piece. So 3 times the absolute value of x plus 2 equals 3. Like before, that we have another addition of 2, but we can't access it until the absolute value bars are off. So right now that plus 2 does not happen in this step. We move on to multiplication and division. We have this times 3 in front. So we want to take care of that by dividing by 3. And then we get the absolute value of x plus 2 equals 1. Now remember what absolute value says. It says the distance, whatever inside of here is, from 0 is 1. Well, remember on the number line, if we're at 0, if you're 1 away from 0, you could be at 1 or -1. So the way we solve absolute values here is we say that what is inside of here equals the positive and negative of what it equals. Notice by doing that, our absolute value bars went away because we consider that 1 and -1 are 1 away from 0. So that's kind of the tricky step. Be sure to put that on your cheat sheet. But once we get here, it's kind of like the quadratic formula. It breaks up into two equations in one moment. We need to subtract the 2 off of here. And that's where it breaks up into 1 minus 2, which is negative 1. And then the other one is negative 1 minus 2, which equals negative 3. So absolute value actually had 2 solutions for this. We'll see why in a moment when we graph. So remember our absolute value, you see absolute value bars and you're thinking, ooh, it's a V. Just knowing the shape is half the battle. Now it's figuring out where it goes. Remember, it's what the vertex is, whatever makes that 0. So our vertex is going to be negative 2. And then the back number stays the back number. So our vertex is at negative 2, negative 4, which is right here on the graph. This 3 then tells us the slope of this. So 3 can go over 1. So we are going to rise 3 and run 1. So let's do that from our vertex, rise 3, run 1, and so forth. And then we do it in the other direction to get that V, the mirrored points. Go here. And we have our absolute value. Now we want to see the output is negative 1 or the y is negative 1. Well, y is negative 1 right here. So when I trace it over this point, and then we trace it over again, and this point. And if we trace it up, this has an x value of negative 1, and tracing up here has an x value of negative 3, like our equations said they would be. So we can see why there would be 2 solutions with absolute value. Okay, let's see one more. And that is m of x equals 6. Well, our m of x function, when we look back at that, is going to be x minus 1 squared minus 3. And hopefully you're looking at this exponent of 2 and realizing, oh, exponents of 2's make u's. They make the parabola. So in a moment when we graph, it will be a parabola. But let's solve with our reverse PEMDAS first. So addition, subtraction, we work our way up. We can get rid of this minus 3 by adding the 3. And so we get x minus 1 squared equals 9. Again, that minus 1 is trapped by parentheses, so we can't access it for the addition step here. We don't have any multiplication. Like if there is something in front, we would take care of it like we did before, but there's no number there, and so we don't have any multiplication to take care of. Exponents, though, we have a squared, and when we want to undo an exponent, we do a root. So a squared will be undone by a square root. If we square root one side, we have to square root the other. Whatever you add to one, you add to the other. And the reason for doing that is because the square root and squared will cancel, leaving us x minus 1. But do you remember back to the quadratic formula? X is equal to the opposite of b plus or minus the square root. Anytime you have a square root of a number, you get the plus and the minus of it. So the square root of 9 is 3. So we actually get plus and minus 3. That's because 3 times 3 is positive 9, but negative 3 times negative 3 is also positive 9. So that quadratic formula actually helps us remember the plus and the minus. And then we have the last step of plus 1. So one of them is 3 plus 1, which is 4. The other one is negative 3 plus 1, which is negative 2. Go ahead and pause the video. I want you to graph our x minus 1 squared minus 3 here and see if your graph is correct of where it outputs 6. Okay, check your vertex. Should be 1, negative 3, and then we build up by the odd numbers. Up 1 over 1, up 3 over 1, up 5 over 1, And now we take a look, the output of 6 is here, so when we trace it over, this point has an x of 4, this point has an x